Part C, a squared times b squared minus 1/4. Okay, just so we don't forget, is there a GCF between those two terms other than 1? No, not in this case, but it's a good idea to get in the habit of checking it. And then write down the formula. Now, this is why I use capital letters, because you'll see a lowercase a and a lowercase b in some of the problems. That's different than uppercase a and uppercase b. That's what I use in the formula. So a squared minus b squared, what does that factor to be? A plus b times a minus b. Write it down until you memorize it. And then you look at this first term. Okay, this is a squared, right? A squared times little a squared times little lowercase b squared, that is a squared, right? Then uppercase a is what you would square to get that first term. So what would you square to get lowercase a squared times lowercase b squared? A times b. Does anybody see a trick? The trick is this. You can take the square root of something like a squared times b squared. The square root breaks up over multiplication. And that gives you the square root of a squared times the square root of b squared. In other words, you don't have to write this out, but you can think about it this way in your brain. Individually then, what do you square to get a squared? In other words, what's the square root of a squared? That's a. What's the square root of b squared? That's b. In other words, you could look at both factors separately. What do I square to get that lowercase a squared? Oh, a. What do I square to get that guy? Oh, b. Okay? By the way, there's a problem with this statement if a and b aren't both non-negative, and we're going to talk about that when we get to radicals in the next section. But that if we assume a and b are non-negative, then that formula is correct. Okay? All right, so what's acting like our uppercase a is the lowercase a times lowercase b. Okay, and then what is uppercase b? In other words, this is b squared. 1/4 is b squared. What is b? What do you square to get 1/4? That is true, 1/2, right? Because 1/2 times 1/2, that's 1/2 squared, is equal to 1/4. Okay? So once you've identified uppercase A, uppercase B, plug in the formula, you're good to go. So what do you get? What's uppercase A plus uppercase B in this case? Little ab, right? Plus what? 1/2. And then what's the other factor? Little ab minus 1/2. That's it. Any questions on that? All right, let's try. Oh my goodness, what the heck is going on here? A squared minus 8a plus 16 minus b squared. Okay, look for a GCF other than 1. Do you see one? I don't. But I should probably mention that to get you in the habit of it, looking for it anyway. It doesn't look like the difference of two perfect squares, does it? In fact, when I see 4 terms, I usually think a method I showed you the other day. Remember what it was? Grouping. But very quickly, I think you're going to see if you try to group, no matter what order you do it in, it's not going to factor by grouping. So this one would be hard to see if I just don't tell you the trick. And so let me do that. Let me tell you the trick here. You guys see the first 3 terms? Oh, you know what? Yeah, no, I can show. I was going to say we could save this for later, but no, this will work. You see the first 3 terms? Turns out if we factor that, it'll be a perfect square. I know, it's not like something you'd probably think of. I wouldn't have thought of it when I was in your shoes. But the first 3 terms, think of that trinomial and factor it. First, use the 2 parenthesis method. So if you think of the FOIL method, we're reversing FOIL. What would the first multipliers be to get us this a squared right here? A and a, right? And then since there's a 1 in front of the a squared, again, I'm just looking at the trinomial. You would need 2 numbers whose product is what on the end for the last terms? 16, but the sum has to be negative 8. So what are they? Minus 4 both times. Does everybody see that? That trinomial that's part of the bigger overall polynomial factors to be a minus 4 times itself, a minus 4. So we could rewrite that. We could rewrite the original problem as a minus 4 quantity squared, and then we still have that minus b squared, don't we? Does everybody see that? Now is it the difference of two perfect squares? It is. So let me write the formula down again. The generic formula for the difference of two perfect squares, capital A squared minus capital B squared is equal to capital A plus capital B as a quantity times a quantity, capital A minus capital B. So can you identify me what's acting like capital A? What are you squaring to get this guy in front here?
A minus.
Yeah, the entire quantity, A minus B, 4 actually, isn't that acting like capital A? Little a minus 4, isn't that acting like capital A in the generic formula? Does everybody see that? And what's acting like capital B? Well, just look at this guy, the little b squared, and think, oh, what am I squaring to get b squared? B. So capital B is lowercase b in this case. They match up nicely. So now if we apply the right-hand side of the formula, this side, what do we get? What's capital A plus capital B in this case? Okay, parenthesis. Okay, just for emphasis, I'll leave the thing I'm calling capital A, little a minus 4 in parentheses. So that's the A part of the A plus B in the generic formula. And then what the plus B part's just going to be that guy, right? Now, are the inner parentheses necessary at all? No, not in this case. But they're there for emphasis. I'm emphasizing the fact that this is the guy that we call capital A, right? And of course, this is capital B. So there's your A plus B, capital A plus capital B. Okay, then capital A minus capital B in terms of what we're given in this problem would be what? Just take these guys, and instead of a plus right here, what do? Put in a minus. Now, the inner set of parentheses here, are those necessary? No, not at all. We're just emphasizing once again, this entire quantity, A plus B, is our capital A from our formula, and this guy is, little b is exactly equal to capital B. So in the final answer, can I just drop those inner parentheses? Yeah. So we could write it as A minus 4, the quantity A minus 4 plus B times the quantity A. Did I write that wrong? Yeah, sorry about that. I think I was thinking ahead on that one. A minus 4. That's why you guys were looking at me funny. I was wondering. Okay. And then A minus 4 minus B. Does that make sense to you? Now, if the second part turned out to be a quantity, like A minus 4, then those inner parentheses would be necessary because you'd have to distribute the negative.